Hello and welcome to your channel AWS Cloud Bytes. I'm your host Bhavesh Kumar. Today we are going to explore Elastic Kubernetes Service or EKS deployment using Terraform. I will run through a lab provided by a Cloud Guru platform. They are good and I will recommend buying a subscription if you can. Let's look into the objective today. The objective is to create an EKS cluster, have an Nginx pod, a couple of Nginx pod running, and then we are going to destroy the cluster. So things that we are going to perform is we're going to have AWS CLI configured. And once it is configured, we are able to communicate using Terraform on AWS. So using Terraform, we'll then create a cluster and perform deployments of a couple of Nginx pods. Once we are able to verify all these pods are active, the cluster is active, then we are going to destroy the cluster as it is going to be an expensive cluster if we keep it running. So let's look into the lab today. Now I have opened two windows over here. First one is console, AWS console, where I have logged in and I can show you that there is no EKS cluster running. This is all brand new login. There is no clusters running. Let me click on this and there are 0 clusters. Now let me go to the second window, which is a terminal. I have done an SSH onto a machine that was provided by the lab and I have done the login here. If I show you the files using ls, you can see there are a couple of files and a folder. So I'll go to the lab folder, and if you go to the lab folder, you'll see there are 4 Terraform files: main.tf, outputs.tf, terraform.tf, variables.tf. Now let's look at the terraform.tf, which is the file that has the providers. And the way this is set up is that you have provider. Under required providers, you have AWS, and the version that is required is mentioned here. Then you have Kubernetes version, and this is basically for a random string. Then you have a TLS version. So we are done with this file. We will just quit out of that file. And then next file that I want to show you is variables, because that's the input. And you can see there is only one input, which is the region, AWS region that you're looking for. And by default, it is US East 1. So I will again come out of that file. The third file that I will show you is main.tf, which is the actual file that has all the resources that will be created. So you can see the provider as mentioned here, and region is coming from the variable. Then you have a data that is a resource, primarily providing information about the availability zones. Then this is a local variable, basically an expression that is taking guru-EKS and then putting a random string so that you have a unique string for the cluster name. And this is just a resource being picked. Random string is what is being used here. So that's what it is. The length is 8. Then you have first module, VPC module. It is coming from AWS VPC modules. Then the name of the VPC will be guru-VPC. There is a CIDR range. There is an AZ that is being provided, subnets. And this is all VPC stuff. The next one is around EKS. Now this EKS is basically, you can see that it is using the Terraform module for AWS EKS, and it is providing a version. The cluster name will be local.clustername, which is basically over here. You can see the cluster name was under the expression. This one is a cluster name, which is guru-EKS and a random string. Okay, going back to the cluster name now. The cluster version is also provided 1.24. Then VPC ID, this is an implicit dependency because it needs the VPC ID. So first the VPC will be created by Terraform, then the VPC ID will be available. Once it is available, that information will be passed to this particular module. Next one is your VPC private subnets. Basically, again, the VPC private subnet information will be passed. Cluster endpoint, public access is true. Then you have some node groups, EKS node groups, and this is again under the same module of EKS. You have first node group, then you have a T3 dot small instance type defined for this particular node group. Minimum node size or the node group size is 1 and maximum is 3, while the desired capacity is 2. This is number 2 node group, and then similar instance type, you have min, max, and desired. In this case, the desired is 1, max is 2, while min is 1. So you have this data that is picking up this ARN EBS CSI policy. Now there is another resource that we are building. Basically, this is a new module, IRSA EBS CSI, and you can see it is creating a role. The role name is going to be the same, EKS, Terraform, EBS, CSI role, and then the cluster name is being provided. So this is a dynamically built role name. It's an expression being used, and the role policy errands are coming from the data, which is here. In this one, you have this data being picked. So you can see that the ARN is coming from that particular resource. OpenID Connect or OIDC fully qualified subjects, they're coming. This is a hard-coded one. Then you have this resource. So EBS CSI resource is over here. This is an add-on type, and this is the resource name. Over here also, this is the type, and this is the data type, and this is the local name. Same thing, it is referencing to the cluster and the driver and the role. This is using the role from the module that we just saw, this one, IRSA EBS CSI. This is the IAM role ARN. The role ARN will be created once Terraform executes this one. Yeah, that's the end of the file. I have all this info. What I'm gonna do is I'm gonna configure the CLI, and it will ask about the access key and secret. So I'm gonna move this screen to a different window and provide that access key and secret information. Once I'm done, then I'll come back. Okay, I'm done with the configuration of AWS CLI. Now, once we are done with this, we are ready to look at the Terraform scripts. And if you remember, if you need to run Terraform, you need to do Terraform initialize. So all the dependencies and the modules that are referred in our Terraform scripts, they will be downloaded. You will see that it is initializing the backend, downloading all the modules. You can see VPC modules, IRSA, EBS, CSI module, you have EKS module, and all other dependencies will be downloaded based on the versions that you have set up. If it is not set, then the latest version will be downloaded. Now our Terraform initialize has been successful. I want to do a Terraform plan to show you things that it is going to create. So given the scripts that we ran through a few minutes back, you can see that things that it is going to create in AWS. So let me do a quick walkthrough. Okay, so this IAM role will be created, this resource. Once the IAM role will be created, this is going to be a policy, and then you have the cluster policy. All these policy attachments will happen. Then the security group will be created, and there are some roles. Once the rules will be created, so many rules, ingress and egress rule. I guess this is mostly ingress over here. Then you have this another policy. Then you have this NAT gateway, internet gateway, NAT gateway getting created. your VPC NAT gateway, you can see. Then you have the route table configurations. Once we are done with that, we have all these private and public subnets. Then this is the node group for EKS, and node group 1, you have all that information. Then you have the node group 2, this one coming. Once you have node groups, these are just a launch template, I think. They will be added under launch template, or you have the policy document as another resource. This is KMS key. We need to apply the plan, and I want to approve it automatically because we have looked at the plan. So, type over there. No. So we'll run the Terraform apply, and with auto approve, we're doing auto approve because we don't want to feed in yes again, because otherwise it will ask you for a confirmation. So you can see that it has started creating all the resources that were mentioned in the plan. And while it is running, I can show you. It will take maybe a couple of minutes, but you can see that it is now creating a cluster, and it has created all other dependencies for this cluster. I'll pause the video and we'll come back once the cluster is created. So I just wanted to show it is still creating. It is more than 10 minutes for the initial EKS cluster, and the Terraform is still working with the node group. So you can see it's still work in progress. I'll pause it further and come back once it is done. Okay, it took like 25 minutes, 28 minutes in total to get through the script. You can see the script has executed. And let's go to the other tab. And let me refresh this. You can see now the cluster is active. And the name of the cluster, as you can see, it is guru-EKS and then 8 random characters. And if you look at the resources, you have all these pods available. They're running for last 15 to 20 minutes. And then let me look at the cluster. We have 3 nodes. Desired capacity was group 2 was having 1 node, while group 1 was having 2 nodes as desired capacity. We have initialized our Terraform. We look at the plan of the Terraform, and then we have applied the Terraform scripts. So we have the EKS cluster. We need to configure the kubectl to interact with the cluster. So I'll go to this, and within the same, I'm gonna paste this particular command where you are looking at the region. Region is the Terraform output of region. And then you have the update, and we are taking the output of the cluster name. So let me run this particular command. If I do kubectl get cs, and you can see that you have etcd1, 2, 0, scheduler, controller, all of them are in healthy status, and there's no error. Let's look into the deployment of Nginx pods. So in order to get the Nginx, I will go out of this. He was having an issue earlier getting this file, and if I look at the file, this is Nginx tf, and I will move this to lab. So let's move back to the lab. And then let me show you the file first. So vim nginx tf. You can see that there is a data section where the remote backend is local, and then it is storing the Terraform state in this terraform.tf state file. This is the cluster which is coming from the Terraform remote state.eks output. This is the output of the cluster name that we just created, and this endpoint is again the cluster endpoint that we just created. And this is Kubernetes deployment of nginx and some template information in the spec of it, what nginx image it is going to use, what will be the port, how much memory, all that sort of things. Let me do the plan. As we have added nginx.tf file, there will be additional resources that are going to be created in the plan. So you can see it is going to add 1, change 0, and destroy 0. Let me add Terraform apply and then auto approve what it is creating. Let's wait for it. It may take a couple of minutes, so I'm gonna pause the video. Okay, so the deployment of nginx was done. Okay, let's go to the deployment. We have to go to the workloads. You have the deployments, and the deployment that was created just now for nginx was long live the bat. And that's the same thing. If I perform this query over here, this is kubectl. This deployment was just done, so you can also get the same information around deployments over here. So you have the long live the bat. Now, before we destroy the cluster, as you can see that we have Terraform EKS cluster running, and we have a couple of deployments over here. So you have the core DNS, you have the EBS ESI controller. These are kube system, and then this is the nginx deployment that we did. Once we are done with this, let's look at the state file. So if I write Terraform state list, you can see the resources that were created as part of this Terraform script. Let it load. So all these resources were created. And finally, as part of closure to this particular lab, I'm gonna destroy this Terraform resource set that we have created because it's gonna be expensive. I have not given the confirmation, that's why it's gonna ask the confirmation. It is looking at the state file, and given the state file, it will ask me that should we delete 59 resources that it created, and we'll say yes. Now it will start deleting all these resources. It will take a while before it deletes because creation was around 28 minutes. So even if I go over here and refresh the cluster, nothing will show. It will take some time to delete the cluster. But that is all I have for this particular lab. Please let me know if you have any questions. This is the end of the episode. Thank you for watching. If you liked the video, please like, share, subscribe, and press the notification bell icon for future updates. This is your host, Bhavesh Kumar, signing off. Thank you so much.